In this video, one will be able to understand the energy management centers and what are the major components in energy management centers. So I am Professor Mohan BS, working as Assistant Professor in Department of EEE SAPIT. So before going further, let us try to understand or revise on the two videos that we have in this course. So you can pause the video, try to find the solution for these based on the previous video, a small revision so that we can understand it much better and move forward. So I hope you have got the few answers. So let us see one by one. So the first parameter down, North American reliable operation, we have 7 key parameters. The second going down, dash generators are used for generation, we use synchronous generators. And then second across, planning and monitoring of power system operation is carried at which dispatch center? State load dispatch center. The third one going down, automatic generation controls is responsible for maintaining dash power balance. We have seen that under objectives of control, it is for active power. Third going across, at dash state the equality and equality constraints are satisfied, however spinning reserves are reduced. So this we have seen in an alert state as I bar. I bar indicates and inequality constraints are not still satisfied. And then the fourth one down, dash controllers are commonly used for reactive power control. As we have seen in the key parameters, it is HVDC or fax control devices. Fifth one, dash constraints set the limit of different operating parameters. There is inequality constraints of different operating parameters. It might be frequency, it might be voltage, right? So these are your inequality constraints. And then the sixth one, dash constraints are related to the balance between your generation and load is your E, that is equality constraint. And then the seventh one, there are dash types of energy control centers that we will be seeing them now. There are actually 4. And then eighth one, maximum power that can be transferred over the lines that you have seen in the video with respect to objectives of control is 1.5 times of your Pmax. Right. So these are the answers. I hope you have got them all right. Right. So let's move on forward. So what is energy management center? So now the first state which got EMC is Kerala, and in Thiruvananthapuram in the year 1996, or Trivandrum is what we know it today. This is the first state which actually implemented the emergency control centers in Thiruvananthapuram in 1996, in the month of February. And we have ample amount of job opportunities for electrical engineers in energy management system. All that you need to do is study some, programming language with respect to either C#, Python, C++. You can also take up a job or career with respect to be of energy efficiency as being energy auditors. So the control of modern power system is extremely complex. So modern EMCs are embedded with number of functions. And we all aware they consist of software and hardware. So monitoring is done for what and controlling is done for what. Monitoring is automated. Controlling is both automated and manually operated. The functions of EMCs are divided into 3 subsystem blocks: dispatch, data, and security subsystem. Dispatch, what it has to send out? It has to send out, right, with respect to these functions are monitored and controlled over unit commitment, economic dispatch, automatic generation control, and demand forecasting. Data subsystem. This subsystem is essentially for data acquisition and processing. It contains the unit of SCADA, state estimation, and all the associated alarms and display. Security subsystem. The function includes a secure monitoring, contingency analysis, decision of control action based on the state of the system. Now, there are different hierarchies which are classified. level 1, level 2, level 3. So level 1, what are these? And how much time do they take is what is being defined under level 1, level 2 and level 3. I repeat, so what all are these? What all parameters are set? What all control actions have been placed on level 1, level 2, level 3, and how much time do we have for each levels? The first one is for long, the second one is for few minutes, the third one, it has to be, these control actions has to be taken in few minutes, right? So the keyword is cult fit, where U and C stands for unit commitment, and L stands for load forecasting, T for trading, and the duration time, as said, it is for long duration. And here we have EDOP, which is economic dispatch, optimum power flow, and interchange evaluation, which has to be, these control action has to be done within few minutes. And then the last one is within minutes. That is automatic generation control, voltage control, state estimation. These control action has to be taken care or done in few seconds. So level 1 function, as they use statistical data, hence they use a method called probabilistic method. And the rest, level 2 and level 3, they mainly use they are deterministic in nature, and deterministic methods or models are used. So what is deterministic model? Parameter values, and they are depending on the parameter values and initial value. Probabilistic, they have statistical data, they incorporate randomness in their approach. And now let us see the major components in an energy system. So the major components are SCADA, computers, user interface, that is GUI or UI, and then application, different application softwares. So supervisory control and data acquisition system has two subsystems. What are these two? Supervisory control is one, and the other one being data acquisition. And let us see the rest in upcoming slides. Supervisory control. So what are its responsibility? Display or the control location, the status of circuit breakers, other protected devices, the status of your transformers, capacitance switching, generation regulators, and you name it, all it has to be displayed. The dispatcher at the control center will initiate actions to switch circuit breakers, changing taps, and etc. That means it is not automated. It is being supervised by an operator at a location center, at a control center. Data acquisition. We use RTUs or IEDs, that is intelligent electronic devices, to interface the power system instruments with the control device. The interface communication channel, SCADA by itself has its own protocol for communication, or we use wireless communication and power line carrier communication system. So this is just a small diagram of the structure of remote terminal unit, where you can see different input and output pins, which is split analog and digital, processing unit, power supply, communication port to the main SCADA system. The computers, as we are all are aware of the main functions: real-time monitoring, user interface, operating studies, maintenance testing, simulation studies. Right. So these are the key parameters used under computers, under major components of energy center. User interface, we are aware that how graphical representation helps us to analyze better. Since it's extensive interaction with human beings, modern interface use techniques of animations and extensive graphical representation to make it more user friendly. Application softwares, this section is to implement the various functions discussed, namely for unit commitment, economic load dispatch, state estimation, optimal power flow contingency, and many other. So what you've seen in this video, we've just revised the other two videos that we have under this chapter. And then what is energy control center? The major components of energy control centers. Thank you for watching the video. Please do subscribe to the channel to enhance your knowledge further.